Hi, algebra students. We are going to be writing down notes on slope-intercept equations and graphs today, and you probably have already sort of slogged through the introduction to this topic. I hope you were able to discover a few things about how graphs and these equations are related, and if not, and if that last assignment, that intro assignment, was a little confusing to you, then awesome. I hope that this will help to solidify maybe some of the confusion that you had. So the title of this page is going to be Slope-Intercept Equations. And their graphs, and I'm just going to put slash graphs. Slope-intercept equations and graphs. And so let's think about first what the general form of this is going to look like. So we call these slope-intercept equations because these are equations that are going to include or indicate both a slope and an intercept. And we're going to talk about what an intercept is in a minute. If you think about just in general what intercept means, if you think about football, if somebody throws an interception, then that is something that the ball is headed in one direction and it crosses in the path of someone on the other team and the other team gets it, right? So intercept just means to come in contact with something else. And so we're going to talk about what it means to be an intercept, and hopefully you were able to pick out some slopes and intercepts in that last assignment. But in general, the form of a slope-intercept equation is going to look like this. And we're going to write it pretty big. So y is equal to mx plus b. Now, all of those are variables right now, but we're going to, of course, tell what each of these variables actually stands for. In math, we use letters to indicate unknowns, and so these are all unknowns. They do have meaning, though. Like, what is it that's unknown? So you know from your past that the y is actually the unknown of the output, right? If you're thinking about input and output tables or functions, we know that the y is going to be the output, whereas x is going to be the input. We spent a couple of weeks ago, we spent a lot of time plugging in numbers into the input for x. So y is output, x is input. And these are really the two other letters here, the M and the B, are the ones we're going to be mainly concerned about today, which is, of course, the slope and the intercept in order. So we've talked a lot over the past week about how slope is always indicated by M. So the M here, of course, stands for slope. And this B indicates the intercept. And now not only is it just an intercept, but it's actually what we call the y-intercept. And you might ask me, well, why do we use B? Well, Y is already taken, so we couldn't use Y. And I don't know, why not use A? Who knows? Someone chose to indicate the y-intercept with a B. And so we're just going to jump into some examples of how to use this, how to connect the equation to the graph and vice versa. So actually, for the rest of your notes page here, you should have hopefully a lot of blank space here at the bottom. We're actually going to need to draw in 6 coordinate planes. And so I would kind of space them out as best you can. Maybe make them about maybe 6 lines each. So, and I'm going to do 2. I'm going to do 1 on each side. So just so you know what I'm talking about, 1, 2, 3, 4, 5, 6. And then, we'll draw our y-axis in. We'll draw our x-axis in. We'll do the same thing over here on this side. So just sort of evenly space them. Remember, we just want them to, be as straight as possible. So here's our x-axis, y-axis, x-axis, y-axis. And we're going to need 6 of these. So 2 on each line. So I'm going to go down here and skip a line and do another one. 1, 2, 3, 4, 5, 6. And then we'll cross that. It's helpful if you can cross it on an actual blue line. It just keeps things nice and straight. Maybe the 3rd line down. And then we'll cross this one. So there's 4. And then we're going to come down here and do the last 1, 2, 3, 4, 5, 6. And then we'll cross it. And same thing here. 6 lines down and cross it. And we're going to go through, of course, and remember we want to make the, have the little tick mark. So go ahead and 2, 3, 4, 5. Make at least 5 on each line. And I like to go in the in-between. So in-between and go up. Make sure you make at least 5. And again, try to evenly space them as much as possible. 3, 4, 5. 1, 2, 3. I would speed up the video here, but That's way too complicated. And also you need time to mark off yours. So 4, 5, 1, 2, 3, 4, 5. And the last couple. And again, the better, the more evenly you space this, and the less you just kind of go through and do it quickly. That's why I like to use the up and down lines to sort of give me an idea of how far they need to be spaced first. Sort of one in between and then one on the line. And then you can space out on the x-axis. All right, so you should have 6 coordinate planes that should look more or less like this. And if you're still drawing, pause the video, and that way you can finish all your coordinate planes before we jump into the first example. So we're going to focus in on this graph here at the beginning first. And so the first thing we're going to look at is given an equation, given a graph, we're going to write an equation. So given, I'm going to write this off to the side, given graph, can we write equation? And so that's what we're going to do 3 examples. So example 1, 2, and 3 will be these. So we'll put examples 1 through 3. All right, and so the first thing we're going to do is we're going to look at a graph. So I want you to put a point at 0, 0. I want you to put a point at over 1 up 3. So a point at 1, 3. And then I want you to put a point at negative 1, negative 3. So over negative 1, 1, 2, 3. It's going to be like this. And so those should be more or less, if you marked everything off correctly, in a straight line. And so we're going to draw a straight line through there, put arrows on the end of it because it keeps going on and on forever. And what we want to do is we want to write the equation. We have the graph here, and so these are points. Remember, these are input and output points. And even, I'm going to label them for this first graph just so we can see. So again, remember, these are input-output points that have been run through a machine. Negative 1, negative 3. And so we want to know, what did the equation look like? What was the equation for the machine that gave us these input-outputs that were in a line that we could draw a graph from? And so there's a very easy way of doing this because we know slope-intercept. So if we can pick out a slope and we can pick out an intercept, we have a bunch of input and outputs. We know that this is containing input and outputs. And so we are going to want to find the slope and the intercept, and all we have to do is plug in slope and intercept into this equation. And so let's look at our graph. Can we pick out the slope? So I'm going to make a little list here. I'm going to say, okay, what is my m? What is my slope? Well, I'm going to find 2 intersection points. We've got a bunch marked here. Slope is rise over run. So 1, 2, 3, rise 3, and then run 1. And so the slope here is 3 over 1, which also is the same thing as 3. All right, so convince yourself of that. Make sure you understand that the slope there is 3. And now we're going to look at B. So B is this y-intercept. Well, again, a second ago we were talking about what an intercept is. An interception in football is when the ball comes in contact with the other team and they touch it, they take it. And so what we're going to look for is if this line is traveling up, 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 at what point does it intercept, or at what point does it run into the y-axis? So now remember, we're looking for y-intercept. So if you're on this line and you're driving or flying or walking, whatever, along this line, at what point do you run into the y-axis? And you run into it right here, right? Well, on the y-axis, what is that value? Well, that's at 0. So my y-intercept here is at 0 because it hits the line, it hits the y-axis at the number 0. And so now, here are the 2 points we need. Now, our x's and our y's, our inputs and outputs are all different, right? So we're just going to leave input and output as y and x because there's a bunch of different pairs. But what we're going to do is we're going to plug in these numbers that we have for the slope and the intercept. So remember, our goal is to write an equation, right? What is the equation going to be? Well, it's always going to be y. So I'll just write it down here. Y equals the slope, which in our case we said was 3. We plug in a 3 where we see the m. Then we're going to write down x, because that's our, stands in for our inputs. And then plus the value of b. Well, what was b? B was 0. And so our equation for this line, or the rule that the machine had to go through to create these input and outputs, has to be y is equal to 3x plus 0. Now, we know that anything plus 0 is actually just itself, so you could actually clean this equation up a little bit, and your final answer would be y is equal to 3x. And so convince yourself that, you know, this follows the rule that every x value is multiplied by 3. That gives this. That gives my inputs and outputs. And this is the equation that would create this line from the inputs and outputs. And so, again, the moral of the story is if you can find the slope and you can find the intercept, all we have to do is plug it into this form. So let's look at another one, and let's see if we can convince ourselves that this is always going to be true. So on the next coordinate plane, I want you to put a point at 0, -2. So 0, -2 down here. I want you to put a point at -3, 0. So on the x-axis up here. And then I want you to put a point at 3, 1, 2, 3, and then down 4. So over 3, down 1, 2, 3, 4. So it should be on that line right there. All right, connect those. All right, and so again, we want to write the equation. So we're going to pick out two things. We're going to pick out our slope. We're going to pick out our intercept. So what is the slope here? Well, again, find an intersection point, count to the next one. Remember, we're always going from left to right, and so we're going to count down 1, 2. So the rise is -2, but the run is 1, 2, 3 over 3. And we could double check that up here. Do you go down 2? Yes. Do I go over 3? Yes. Remember, we're counting spaces and not just lines. So the slope here is -2 over 3. And then what's my intercept? Where does this line, if I am, you know, like Slope Dude, skiing along this line, at what point do I run into the y-axis? And I run into it right here. Well, what is that value? That value is -2 on the y-axis. So my b value here is -2. And now all I have to do is plug these numbers into this form. So the equation here, and I'll write it down here, is going to be y is equal to, always y is equal to, the slope, which is -2 over 3x, and then our b value here is -2. Well, it's always plus the b value, so we could write plus -2, but that's actually the same thing as -2. And so our equation, I'll write it again out here in space so we can actually see it. -2 over 3x minus 2 is the equation for this line. The equation that gives us the inputs and outputs that we graphed as ordered pairs to form this line. So convince yourself again that this is the slope, this is the intercept, and all I do once I find them from my graph is plug them into the general form of a slope-intercept line. All right, we're going to do one more of these where you're given the line and you need to write the equation. And this is going to be a really interesting one because I want you to put a point at 0, 3. So put a point right there. And then I want you to draw a straight line through it. And so we talked a little bit about horizontal and vertical lines, or we looked at horizontal and vertical lines in that introduction assignment that you all did. And so if it made little sense to you then we will clarify it hopefully here. So we've got this line. We want it to be written in slope-intercept form. So we look, well, what is the slope here? Well, the slope of any flat line is 0. And what is the intercept here? The intercept, well, it runs into the y-axis at 3. And so we've got a slope of 0, a intercept of 3. So let's plug that in. Y is equal to mx plus b. M is 0x plus b, which is 3. Well, 0 times anything is 0. So this piece right here just becomes nothing. And so we actually get the equation y is equal to 3. And that is what we found in our introduction activity, or you should have, is that anytime you type into Desmos a y is equal to equation, it's always just going to be a flat line that runs through the y-axis. It looks like an x-axis, right, because it's flat, but it's a y is equal to graph. The same thing about an x is equal to. X is equal to would always just run through an x-axis. And so just keep that in mind as far as horizontal lines or horizontal graphs or vertical graphs, is it's always going to be either just y is equal to or x is equal to, in this case because there's no slope. All right, so those three examples are examples of graphs which have, we're given the graph and we are asked to write the equation. So for these last three graphs down here, we're going to do something a little different. We're going to do for the last three graphs, we're going to be given, and I'll write it down here, if we're given an equation, can we draw a graph? And we can, because we know what slope is and we know what intercepts are now. So let's look at just an equation, and then we're going to draw the graph. So the equation for this graph is going to be y is equal to 2x plus 3. So you're going to be given that equation, and you're going to be asked to graph the line. What would this graph look like if I did a bunch of inputs and outputs, and if I then plotted them on a line? Now, of course, you could choose a bunch of inputs and outputs and come up with a table of values, but we're trying to make life easy, and we know that this is the slope. So 2 is the slope here, and 3 is the intercept. And so you can just label those. We know our slope, we know our intercept, and so what we're going to do is we're going to start at the intercept, because I know where the y-axis is. So this equation is telling me that the graph starts, or the graph intercepts, the y-axis at 3. So all I'm going to do is I'm going to go to my y-axis, and I'm going to put a point at 3. It's kind of like the one we did just over here. So I'm going to put a point there. That's where it intercepts. Intercept taken care of. Then I'm going to use the slope to extend my line. So if that's where it intercepts the y-axis, the slope is 2. And remember, a slope, if m is 2, that's the same thing as, how would I write that as rise over run? It's a whole number, so it's 2 over 1. So a slope of 2 is telling me I'm going to rise 2 and run 1. So that's what I'm going to do here. 1, 2, and then I'm going to run 1. And so I should have a point here. I'm going to sort of backtrack and go in the opposite direction. So imagine where this line's going to be. This means I need to go down 2, 1, 2, and over 1 in the opposite direction. So a point there. A good line in algebra class always has at least 3 points. Now, you could keep going down 2 over 1, down 2 over 1, and extend this to the end of your graph, but you should at least have 3 points, unless for some reason it's a flat line or an undefined line. If you've got a graph with a slope and an intercept, you need to have at least 3 points when you graph it. And so this is what the graph of y is equal to 2x plus 3 is going to look like. All right, let's look at our last 2 graphs. And again, we're going to practice given an equation, draw a graph. So let's try this one. You may even want to pause the video and try it on your own. Let's try one with a negative slope. So negative 3/5 x plus 1. And we want to put this on the graph. So remember, label your slope, label your intercept first. What is my intercept? What is my slope? I'm going to put the intercept on, and then I'm going to do the slope. So if you pause the video and tried this on your own, you can double check yourself now. The intercept here was at 1. Positive 1. Now, if this had been minus, of course, we would have needed to be down here, but the intercept here again was positive. Positive 1. Slope is negative 3. So rise negative 3 and then run 5. So we're going to rise 1, 2, 3, go down instead of up. Then run positive 5 in the positive direction. 1, 2, 3, 4, 5. That looks good because I know it should be going downhill, right? And then I'm going to backtrack in the opposite direction. So instead of going down and over to the right, I'm going to go up and over to the left. So we're going to go up 1, 2, 3, and then we're going to go over 5. It's okay if you have to kind of go through my equation. Almost got in the way there. And my graph is, I think this side of my axis is a little steeper than this side. I didn't get these exactly lined up as they should, but it's pretty darn close. Maybe my points aren't exactly in line here, but that's the nature of a handwritten graph. So hopefully yours looks better than mine. Slope of negative 3/5. Remember, slope dude going downhill. That looks good. Intercept of 1. And so that's what the graph of y is equal to negative 3 over 5x plus 1 would be. All right, last example. And then you're going to practice both of these things, both given a graph and write an equation. And you're going to practice, if you're given an equation, how would you draw the graph? And so this last example is going to be y is equal to x minus 1. X minus 1. And I want to do this one because when you go to label your intercept here, of course you can see it's negative 1. We want to take the negative with it. But what is the slope here? What is there actually in front of that x? Well, I hope you're saying in your head, well, Miss Wallace, when there's one x, when there's just an x, there's really one x, right? And so the slope here is 1. Now, again, we want to keep in mind that a slope of 1 is the same thing as we have to make it a fraction to get rise over run. It's going to be 1 over 1. And so for this, our intercept is going to be at negative 1. So we're actually going to go down on the y-axis. And then our slope is going to be rise 1, run 1. So up 1, over 1, up 1, over 1, up 1, over 1. And so we could just keep going. And then we'd go in the opposite direction, down 1, over 1, down 1, over 1. And so again, 3 points is all you need, but our slope of 1 is really easy to just sort of turn out really quickly. So that is the graph of y is equal to x minus 1. So in general and at the end of the day, we are connecting graphs to slope and intercepts using the slope-intercept form y is equal to mx plus b. Make sure you email me if you have any questions, and good luck practicing.